we're discussing databases, and it's unlikely that you would have only one table in a database. So there will be most time more than one table in database. So when we have more than one table in database, it means we need to define a relationship between the tables. And there could be possibly three relationships between the tables: one to many, many to many, and one to one. And we will see what does they mean. But before going to that, so these relationships are basically we discuss at design time, that how one table is related to another table. When we implement them and when we need to retrieve the information, we need to use these joins in SQL statement. Okay, so these are the four types of joins that are available in structured query language. Inner join, outer join, sometimes there are different names used for them. Inner join is also called as equi-join, and left join is also called as outer join. So inner join, outer join, void join, and full outer join. Okay, and you can see this figure also, the coloring depicts very well that in inner join we want to retrieve the records that have matching IDs in table 2. For example, all the students from this table that are enrolled in certain course. So if this is a courses table, this is a student table, then we want only those students that are enrolled in a certain course. So for that we use inner join. Okay, and if we want to return all the students irrespective whether they are registered or not. Okay, and this result will show us that these students are registered and rest of them are not registered. We use this left join, which is called inner join, and so on. I took this information from W3 schools, and you can go and you can read more about these joins. Now in Visual Studio, this is again from in today's lab, you will be basically building this form. On this form, I just dropped a grid, and in that grid, I basically assign a data source. What I want to show you is a query builder. So we have seen this interface over here. Previously, we just used this option, which is specify columns from the table view, and we select the fields and we go on. Now over here, if you select this column where you want to customize the query, and you click next, and you have an option of query builder. If you click this one, then this interface is appeared, and if you click right, you can add table. For example, we have categories, we can add products, we can add orders, and if you see behind the scene, these are the joins that are being implemented. So inner join, you can see over here, if I add order details, you see multiple inner joins over here. If I close, and for example, I want to see unit price, order date, category ID, and category name, and if I execute this SQL, see, I got these results, and this SQL is being generated by this tool. If I click OK, so you can also call it as a view. In SQL Server, you can create views, in which basically you materialize this query, and you can reuse it multiple times. So you can think of this as a view. If I click OK, this query is over here. I finish the wizard. I can test the query, and this grid basically will show the information that is coming from multiple tables, and I use query builder to retrieve this information. Okay. So these jobs you need to retrieve information from multiple tables. Logical relationship, then you can identify which join is appropriate for you in this scenario. Okay, now let's look at those relationships. One to many relationship. Now this is a customer table, and customer can place an order, and we all know that one customer can place multiple orders. So customer number is a primary key over here, and this primary key is represented over here as well as a foreign key. So you can see that primary key is a unique over here. 250 would not repeat in this table, and this is foreign key. Primary key is represented as foreign key over here, and here you can see 215 is being repeated, so foreign key can be repeated. Now this customer can place multiple orders. Okay, so this is one to many relationship. So in this case, inner join would be useful, in which we have left outer join, in which we get one record from this table and multiple records from this table. Again, you can go and look at details of those joins. But over here, what we need to understand is this table has one-to-many relationship. But in order to ensure that this is one-to-many, not many-to-many, is it possible that this order can be placed by multiple customers? This order is unique. This can be placed only by this user. Now this order cannot be placed by another person because this ID would not repeat it. Okay, other customers will have their own ID. So this is one-to-many relationship. So whenever you will retrieve information, you should know that against this one record, you will get three or more than one record from the child table. Okay, because there could be multiple entries. So this is one-to-many relationship. Same in the student versus courses. One student can enroll in multiple courses. Now let's look at many-to-many relationship. Okay. So in this table we have categories, and you can see that we have 7 categories. Furniture, electronics are also 2 categories over here. And then we have items, and these items have been assigned to certain categories. Okay. For example, sofa is assigned to category 5, and category 5 is furniture, and stereo belongs to category 6, which is electronics. Okay. So for a time being, the items you have, this looks reasonable. But what if new items come with a sofa with new certain gadgets, some embedded devices? So would you put that in furniture, or would you put that in electronics, or in both? If both, then I have to add 6 over here, comma 6. But that's against the rule. We will see the rules. It's not good to have multiple values in a field. So this previously it was one-to-many relationship, that one category can have multiple items. But if new sofa comes in, which has certain gadgets, embedded system in it, then that sofa can be assigned to 2 categories. So this is many-to-many relationship. This is not one-to-many. This is many-to-many relationship. So do you know how we can address this scenario? How we can design the table structure for many-to-many relationship entities? Add a new table. Yes. So what do? We basically bring in a new table. So we remove category from there. We bring in a new table, and in this table we basically do that assignment. Okay, and we identify this as a compound key. Item number and category ID together will be used as a primary key in this table. Okay, and now we can have, for example, an item that can belong to 2 categories. For example, item 4 over here, which is table with DVD player. It belongs to both these categories. So this is how we address many-to-many relationships. So whenever there is many-to-many relationship, you identify, you have to bring in third table, and in the third table you have to basically assign the relationship, which is basically how they can be allocated to items allocated to categories. Okay. And one-to-one relationship is very simple. For example, if you look at this example, we have employee ID and we have some employee information. Okay, and we have another table in which we kept his salary separate, but we use employee ID as a foreign key. Okay, so this is one-to-one relationship. Okay, so by looking at it, looks sometimes illogical that why we have a separate table, why not we can have this salary column over here, just add one column over here. In fact, we are consuming more space in order to save this information. But there are some reason sometimes we need to separate this information from the main table, and that reason could be security purpose or could be business logic. For example, admin is only responsible for registration of the users. He has nothing to do with the salary table. And the number of transactions is very high. If we would have kept in this table, and the payroll system, if it is calculating salary, may get slow or so, or maybe there's a certain security issue. So that's why we may split sometime information that belongs to one entity. We know that this information belongs to this entity, but we kept it in a separate table to fulfill certain objectives. One of the objectives could be security reasons. So this is one-to-one relationship. Against one employee, there will be one salary. Okay, so that covers mostly the we understood why relation tables are important, what are the basic rules, the guidelines we need to keep in mind when we design a table. Now, keeping those things in mind, what do you think are the issues with this table? For example, if we have this database design, what issues you see with this table design? So there are three different, one is there are multiple values in one field. This is one issue. What else? Yeah, we will come to those anomalies. Other than this is design. Which one? Okay. Yeah, same issue with this one as well. What else? We learned one basic rule regarding entities. Yeah, so we have student over here, we have city over here, we have classes over here. The three entities combined into one table. Okay, so which is through experience we learned that entities should be kept in separate tables. So there are a few issues with this table, and there are some definitions which we will go first, and then we will go to the normalization process. So we all know what is data redundancy. Okay, primary key, foreign key structures help us to reduce data redundancy. Normalization is a step-by-step process that helps us to basically design a database that fulfills the application's objective. And through normalization process, we avoid any anomalies in the database design. And what is anomaly? Any irregular database design that leads to certain issues with the operational management of the database, of working of the application, and so on. So we, in order to address and avoid anomalies, we do the normalization process, which is step-by-step process, like identifying entities, assigning individual tables to those entities. So this is step-by-step process, and that eventually helps us to reduce redundancy as well. Okay. So there are three types of anomalies which we will look. The first one is update anomaly. So if we have a table which is poorly designed, and for example, if you look over here, we have a student number, we have course numbers and student details, and then the course details over here. Okay, and if Jones moves from one place to another place, he moved from Edinburgh to Glasgow, then we have to update multiple records in this table. So we know that there are multiple issues with this table design, and one of the update anomaly is that if you are required to update one entry, instead of updating one entry, you are basically updating multiple instances of that entry in a table. So this is update anomaly. Your database should not have update anomaly. If this is update query, it should update only one field. If it is one field, if you need to update one record, it should be one record. It should not be multiple records. So this is update anomaly. Similarly, delete anomaly. If you want to, for example, the same database table design, if you want to delete Jones, what will happen? Jones will get deleted, but along with that you are also deleting course information. So if your website is listing course information that is coming from this table and you delete Jones, then that web page will not have accounts over there. It will be no more over there. So this is called delete anomaly, that you are deleting specific information, but as a result of that you are deleting some other information which is prereq for your working of your application. Similarly, insert anomaly. Okay, that if you want to add user, you also have to add some course, and user may not be loaded in course. Okay, so that's called insert anomaly. So we need to avoid these anomalies, because database operations will be performed on a continuous basis, and if you have these anomalies, then you have to pay the cost. Okay. So normalization basically remove data redundancy and anomalies from database design. That's why this is a planning phase. You need to do a lot of planning. You need to design it, then you need to discuss it with your team, and then implement the changes. You need to discuss the scenario, one-to-one relationship. It may turn to many-to-many relationship. Okay, so you have to brainstorm yourself very well. And the result of normalization process, we get a database design which is very well optimal, and it basically improves, increase the flexibility of querying the information. If you have well-defined database, then you can write multiple queries to retrieve the information. You have flexibility. You can maneuver around. Okay, you have flexibility in writing your queries. sorting, summarization, aggregating the information, again they are related with the QAs. And as a result, you will not require to restructure information. If there will be any update, like in we discussed in applications, that update will not affect the entire application. Okay, that update will be very specific, and very specific portion of the code that is working on that table may need to modify. It will not result in restructuring of entire database. And because it is reducing redundancy, so it also reduces disk space, and your database will be in more optimal fashion. Performance will be good as well. So if this is a typical spreadsheet and you have to design a database from it, so what you can do, again, as we discussed, you can identify the entities. Okay, for example, in this case we have employee entity and we have a department entity. We can keep them in separate tables. Okay, and the third information we have over here is the time card, and we can have another table in which we have employee ID, and we can associate employee ID with the time card being assigned to that employee. So department is linked with the employee table through department ID, and employee is linked with this time card table using this time card ID. Again, simple rule: identify entities, and we can call them as a parent table. Save parent table information and then identify the child tables, and you can work around. So if this is Excel sheet, from this Excel sheet you can identify these tables, and this will serve the objective you want to achieve through your business application. And this is if you stored your information against years, and for every year you are adding a column. So this is not a good database design. It should be in this fashion. Okay, it will be more scalable. So now let's look at the normalization process. So one normalization process, I told you that through my experience that each entity should have separate table. If there's many-to-many relationship, introduce another table. So these are the guidelines, experience which we share among ourselves. But there are certain formal guidelines which people have introduced, and we call them normalization form. And we will look at first normal form, second normal form, and third normal form. There are other forms for fourth and fifth normal form, but we're not going into detail. So first normal form, whenever you design something, we have to check against whether this is first normal form or not. And in that case, we look at are there any repeating groups or not, and we will see what we mean repeating groups. Once we remove the repeating groups, then we go for second normal form, in which we look at partial key dependencies. Then we look at the column critically, how they are related with the primary key. Okay. Once we will eliminate those partial key relationships. Then we go to the third normal form, which basically we remove the transitive dependencies of alternate keys or candidate keys with the alternate keys, in fact, with the primary keys.
All we have to do normalize an exam at all?
It's good. I can give you some.
Like following actual steps, all we have to do?
Oh, well, not exactly. I may ask you, because you asked question, I can give you that this is, you have to design course management systems, and students have these attributes, courses have these attributes, and staff have these attributes, design your tables. Okay, I may not ask you to apply this, but there may be MCQ, for example. What is the issue with this? Is this first normal form, second normal form, or third normal form? Okay, but I will not ask you to perform these 3 steps on this case study and give me results. Yeah. Again, when we discuss the exam, sample exam will be a replica of your actual exam. The question would be different, but nature would be similar. So I will discuss your exam paper maybe second last lecture. But everything which you discuss can come in your exam. That's the baseline. Okay, you have to be. But what sort of question I may ask, we will discuss. Okay, so let's look at the first normal form. Now, because we already looked at certain issue on previous slide, so I think you can easily pinpoint what's the issue with this database design. We have multiple values in same column. So we call them as the repeating groups. We should not have information in this fashion. Okay, because update and delete information would be tricky. For example, if I want to delete the red color from product 1, first I have to basically, instead of delete, I have to write update query and update with, for example, I want green only with green. So your operation would be very difficult. So we want to remove this move repeating group. What I can do?
Create a colors table.
Create color tables. Color is a separate entity, and product is a separate entity. So as we discussed, there should be a parent table. So we can have a now there are different ways to do it. One is to have a separate table like you said, but in first normal form, as mentioned by the people, and these guidelines are for new developers who just started their database design process. So what we can do, we can split this table into two tables, and in second table we can take product ID and we can assign what color this product have. Okay, so this product one have red color and one can have green color. Okay, so we introduce a table, and in this table we can assign the relationship. Another thing you can do is you can have a separate color tables, and color ID will come over here. So instead of 1 red, you have 1 1, and 1 would be red, and so on. So you can also do that as well. That will basically again you are make optimal use of space. Okay. So in this way we can remove repeating groups. Now second normal form is, once you have repeated groups, now look as you can go to the second normal form. And in this table, what you can see over here, we have a compound key over here. So these are two are candidate keys, and both candidate, and this is alternate key. This cannot be a primary key. So we have compound key over here. Customer ID and store ID together represented as a primary key. So it's compound key over here. And we have this third field, which is Los Angeles. Now this purchase location does not depend on customer ID directly. It does not affect the customer ID. Okay. In fact, this store ID is same thing which we have over here. So you can if we don't have over here, still our business logic will work, because we have store ID over here, and store ID tells us what is the store about. Okay. So any field that does not relate to the primary key is placed in separate table. So this key does not relate completely with the primary key. It does relate with the store ID, but it does not relate with the customer ID. So primary key is basically both together. So in this case, what do? We basically split it and we place them in a separate key, and then we use that ID over here. So this is basically partial dependency is being removed in second normal form. Okay. Because it's partially dependent on store ID, but not dependent on customer ID. So once you are able to remove partial dependencies, all the alternate keys which are not dependent fully on primary key, you can put them in separate table. Third is basically remove transitive dependencies, transitive functional dependencies. And we know transitive functional dependency means if A is dependent on B and B is dependent on C, we assume that C is dependent on A. Okay. And we have this example over here. Now this is a primary key, so we don't have compound primary key over here. In previous case, it was a compound key, especially second normal form. So this is a primary key, and against this primary key we have a work department and department name. Okay. Now work department is basically help us to determine from which department this employee belongs. So this is related to this primary key. But what about operations? Does operation tells us about something about primary key? No. That's transitive relationship. So we have to eliminate this transitive relationship, and what we need to do is put the department name separately and use these IDs in the primary table. So in this case we are eliminating transitive dependencies among the columns. So if we do this, our database would be in third normal form. Now when you would be designing your database, in fact the way I have described, you feel it is normalized. You will not go and perform all these steps. Okay, so these are for beginners. If you have experience, you know what's happening, and you can go and do all the steps in one go. You don't need to go and, okay, I have done first step, now I'm going to second step, now I'm going to third step. But for for the beginners, this is a good guideline. Okay. So when we basically remove these redundancies, we remove these anomalies, then our database is normalized form, and then we can start building our application. And we hope that if some new scenarios comes in, some new information need to be stored, we may need to design new table. That new table can easily be linked with existing database design. It will not require restructuring of existing database. Okay, so now we can divert our attention to the certain database performance and security issues. Now, we all know that information is the asset for any organization, and that asset is residing in the databases. So, its performance and security is very critical. Performance, because if the client or customer is not getting information at the time when it is required, then it affects the business. And security, we all know that information is an asset for organization, and we need to protect it. So the company's data must be protected, and it includes all of this that is listed on this slide. We need to provide data integrity. Okay, if data is lost, we need to have certain mechanism to recover that lost data. Especially with ransomware, many organizations lost their data, and the organization that had their data backup, they were able to recover from that data. Rollback features. I'm sure you know that transaction consists of multiple instructions. And some instructions, if it does not execute, that transaction will fail. Then we should have rollback features that basically whatever updates that were performed at a database should be reversed, and database should brought back again to the consistent stage. So we will look at rollback features. If there are concurrent updates to the database, how database management systems handle this. This is also important. Authentication, encryption of information, and recording the transactions that who's doing what are important for auditing as well. So these are the things that include in data security. So let's look at them, a few of them one by one. So data integrity, data should be accurate and consistent. If data is not accurate, it may affect the business. So we need to ensure that database is consistent. And how we can ensure that? Referential integrity constraints. Okay, they may be implemented at database level or application level. Whenever some operations are done on database, we need to ensure that the database should be left in consistent state. It's not like that if student record has been deleted, course information is still over there. That information should be deleted as well. So all the rules that have been specified, the applications need to adhere to those rules. So if we follow those rules, business logic needs to follow certain rules as well, then we can say that we have achieved data integrity in this database. So whenever the operations will be performed, add, delete, database would be left in consistent state. So data loss. So what are the possible ways data can be lost in organization? Sometimes it could be accidental. For example, you wrote a query, delete database, and you committed. Okay. So sometimes it will be accidental, sometimes it may be a cyber attack that result into database, or maybe it's natural disaster, fire. So in those cases, you should have certain policies in your organization that okay, every monthly data would be backed up, daily, weekly, or how it is done. And the backup should not be residing in the same building; it should be somewhere else, and so on. In case of transactions, if some, as I mentioned, operation fails, there should be functionality in DBS to roll back whatever updates that have been applied on the data. Okay, so rollback functionality should be available in the DBMS which you are using in your database management system. If transactions are handled at database level, if your application is handling transactions, then your application should have that functionality. Concurrent updates. We all know that multiple user can access a table and can update a table. Okay, so how database management system manage these concurrent updates? This is a locking scheme. Entire database can be locked, entire table can be locked, even a record can be locked. Okay, once it is locked, it means one user now have access to do operations. Once that user will finish the update or delete operations, then that table will get unlocked, or that record will get unlocked, and other requests, other user will be able to lock that resource and do their operations. So locking mechanism basically ensures that concurrent updates are handled properly, they are synchronized properly in the database management system. And sometimes, especially as I mentioned when I introduced .NET to you, that in .NET there are two ways you can manipulate the data. One is connected you directly go and update the database. Second is disconnected. Disconnected data is you read few tables or database and bring into memory, and you apply updates to that table, and eventually when everything is done, then you go and update the database. So offline transactions are basically, you can think of disconnected data, in which you retrieve the data set, you update whatever operations you do during last 5 hours. Once you operation is finalized, then you can go and update the database. And you can do that process as a batches if there are multiple updates need to be done. Authentications and permissions. Now, we all know that if your system is accessible on the internet, then definitely you need to authenticate the users. And there are different ways to use it. Passwords are used most commonly. Sometimes if things is very sensitive and maybe access to the servers, then biometric authentication may be required. And once the user is authenticated according to whatever permissions he does hold, he can do the operations. In case of web applications, the authentications can be done at 2 levels. One is what application can do, what databases it can connect. Okay, so that is application related authentication. Second is what rights applications provide to the users. Okay, so these are 2 different levels of security. Okay. So you have to think separately whenever if you are going for both sort of authentication. Encryption, again, this is very important aspect when you need to save your data, especially your passwords. If you don't encrypt your password and you're just residing as a text in the database management system, then admin can exploit them. So that's why whenever if you would be developing your application for real world, you apply MD5 hash to convert your whatever password user entered into a string hash and save that hash in the database. And when you're reading, authenticating the user, then you basically retrieve that hash, compare it with the whatever user have entered, compare to hash, and then you can authenticate the user. So encryption is very important. It may be for files, for example, some important files that are being stored in the database, that may be encrypted and so on. But it's important that during development, you should not do encryption, you should not enable it. Because sometimes when you are testing the information, you hard code information in the database, and you want to see whether your module is working or not. Okay, so it's better not to apply to development phase. And again, regarding constraints, it's better not to apply constraints when you're doing development, because if you're doing development and you're applying constraints, you want to check whether delete is working or not, and you have information and you want to delete from parent table, and you have child information in there, then that delete will not work because child records are there. So normal practice is you don't apply constraints while development phase. Okay, once your development is complete, apply constraint, then check your functionality. Okay. And in case of encryption, if the sum happened and you lost your database and you may need to recover it from the backup, and the data is encrypted and you don't know the key, then again you're in a big mess. So it's very important that there should be procedure and policies how encrypted data is managed, how keys are managed, so that in worst case scenario you are able to address those problems. That's it. So this was regarding relation database management systems. If you don't have any question, do you?
Yeah.
Yep.
Do you open up the assignment?
Okay. Regarding assessment. So no question regarding the lecture? Okay, good. Okay, we can go to assessment. Yes.
So you had something in there saying to test. I can't remember what it was saying.
Okay. So what was that? Test what?
Maybe go down to the bottom bit.
Okay.
Yeah. To test your site thoroughly. Down a bit more. Yeah, that one.
Okay. Okay.
So you're saying.
Okay. So for example, if your database is within your solution, then there's no issue. If database is within your solution, but if you're using external SQL server and you submit your information, you submit your assessment without information telling me that okay, you need to install SQL server and you need to modify this file, or the way I have defined connection is in this fashion that SQL server should be running on local machine. So if you're going for SQL server, then you need to ensure the path is correct. But if you're using database within the solution, then again the path is logical path, it's not a physical path. So if you're developing an application and you have access database in C, not in your solution, if your development will work, but when submitted to me, now in my C there is no, your database is not there. So ensure that how you're doing your development. If your database is running within the solution, then things are fine. Okay. Anything else? Okay. No.
For example, there, if you're using MVC and your database is in local DB,
It will come if that problem is logically. Yeah.
Application data folder. So if you're using MVC and you're using local DB, the SQL Express,
Yeah.
then you need to have local DB installed.
Yeah.
Yeah,
I
so-
will just you provide database and I will install it. As
Okay.
Express, yeah. But you have to mention it to me.
Yes.
That it's good when you submit your assessment, you can mention that I have used SQL Express and I used localhost, local DB, the names of all. So you can have one README file or file in which you can mention this. This was my setup, and if it does not work, you may need to do A, B, C, and so on. Okay.
What's the biggest difference between web forms and MVC?
Can you speak loud?
Oh, sorry. What's the biggest difference between web forms and MVC? Is MVC just like a more vanilla version in a sense?
No, web forms are basically MVC is totally different way of looking at your business logic. Okay, you separate the controllers from views, and you have models which basically read the information from the database. If your application is scaling up, then MVC is a better choice. Maintenance would be very easy. Okay, web forms basically are more drag and drop. You are not structuring your business logic. As we discussed, there are 3 tiers. First tier is graphical user interface, second tier is business logic, and third tier is database. If you are going for MVC, then you have these tiers. Okay, but if you're going for the form, then you can think of 2 tiers only. You have web forms and you have database. Okay, within web forms your logic is embedded in code behind or navigation and so on. But in case of MVC, navigation is controlled separately in the controllers. Views are separate, models are separate. Okay, so this is different. So in large scale application, wide level application, they will not be built in web forms. I'm not in MVC there will be web forms maybe when you're creating a views you can drag and drop, but business logic would be separate. The views will be separate, model will be separate, and controller will be separate. Whereas in case of using web forms, then it's your logic is embedded within the web forms. Okay, so that's the difference.
So you still use the stuff like previews and all
Yeah, you can use, especially when you're designing views MVC,
Yeah.
you can do drag and drop. But that is limited to view only. The logic, the controller, they are different. You have to split your logic according to those modules.
You can still use toolbox in MVC.
Yeah, you can use toolbox. Yeah, you can use toolbox in MVC. In MVC, you can define your own classes. You can also define your own classes in web forms as well. But in MVC, you have more flexibility. That's it. Thank you very much.